are ready to rock your world. Welcome to the Johnson Kendro Video Hour.
But it's not an hour.
Oh, but you wish it was. All right, today we're doing section 4.1, quadratic functions and transformations. And we're going to do it in the vertex form. All right, we have the equation y equals x squared. A square makes it a quadratic. We're going to do a little t-chart here. And this is x, and then y equals x squared. So I'm going to choose a bunch of numbers, and then we're going to graph it and see what it looks like. So I'm going to choose 0, 1, negative 1, 2, negative 2. Those are always the best ones to choose to get a good variety. So put a 0 in for x, I get a 0. Put a 1 in for x squared, I get 1. Negative 1 squared is still 1. 2 squared is 4. Negative 2 squared is still 4. All right, 0, 0, 1, 1. Whoa, that's a little off there. All right, so get rid of those. Let's redo this. So I got 0, 0, then 1, 1, then negative 1, 1, then 2, 4, and negative 2, 4. Okay, it looks a little bit like a V, but when it's a squared, it's actually a curve. So it's a smooth curve rather than a sharp V.
Called a parabola.
It's called a parabola, yes. All right, the next part. Here is our vertex form, right here. Right there. And V, the vertex, is H and K. That's just like in the absolute value. And so that's still going to move it to the right or left.
And it's backwards.
It's backwards, and this is still going to move it up or down. All right, so now we're going to check out the steps. All right, so first thing you're going to do is make a shape chart. Y equals ax squared. Then we're going to sketch the shape on the graph and use symmetry to reflect. So you only have to choose half the points. And then we're going to shift the parabola according to h and k. So right or left, up and down. And then the final graph, remember, is a smooth curve, not a V. All right, so we have this graph right here. So we're going to make a t-chart. So we have x and 1/3 x squared. So I'm going to choose wisely here because I don't want to make more work for myself than I have to. So if I want to choose 0, that's great. Put a 0 in for x squared. 0 times 1/3 is still 0. But now I want to choose something so I don't end up with fractions. So what do you think, Miss Johnson? What do you think would be a smart one to pick?
I think that if we were to pick multiples of 3, because that's the denominator, that would be helpful.
All right, so over here I'm going to put in a 3 for x. 3 squared is 9, and 1/3 of 9 is 3. Okay, do I need to pick the negative 3?
No, you do not, because we're going to use symmetry to come up with that.
Oh, we are so smart. So 0, 0 is here. Go over 3 and up 3, that's here. And the symmetrical one would be left 3 and up 3, so right there. You think I should pick another point?
You could.
Okay.
Let's try 6.
All right. So put that in. We got 1/3 of 6 squared, 36. 1/3 of 36 is 12. Now I don't have enough room for that, so we're just going to kind of go with what we have right here and just do a smooth curve from there. So you do your best curvature, and there's our parabola.
That looks beautiful.
Why, thank you.
All right, here's one that this time, remember the standard form for a vertex form is y equals a, and then x minus h is inside the parentheses with a plus 4 on the outside. Our 4 plus a k.
Yeah, K for Kendro, don't forget that.
Okay. The 4 is a k, which means that eventually we are going to go up 4 units. That means that our vertex is at 0, 4. And we didn't change the x value of the vertex at all because there was nothing inside of the parentheses. So we're going to follow the same steps that we did from our absolute value graphing. We make a shape chart. So that's just using the beginning of the graph. You're not using the h and the k. So y equals negative x squared is what we're using. And be really careful here because that coefficient is a -1 times x squared, and some of us have a little bit of trouble with that. Again, I want to choose wisely, so pick easy things. I'm going to plug in my 0. 0 squared is 0 times -1, we get 0. If I were to pick my 1, now this time I don't have to pick any special multiples because there's no fraction. So when I plug that in, I'm going to square my 1, but then I'm going to have to multiply it by -1, and the answer will be -1. If I were to plug in a 2, same thing, I'll square it and then multiply by -1, and I will get -4. Do I need to pick any negative numbers for the chart?
No, because it should be symmetric.
Okay, very good. So we're going to start plotting those 0, 0, 1, -1. Ooh, I noticed something a little different this time. 2, -4. And you can use symmetry to reflect onto the other side. This has an axis of symmetry as well. Okay, now that's not our final answer. And I know that because we have a shift. We need to move our vertex to 0, 4, or we need to shift every point up 4 units. And it will look like this. And connect with your smooth curve. So it's a parabola.
That's pretty.
Thank you. I learned from the best. Okay, here's our next one. This time we do have a shift with an H and a K. So what that means is our new vertex is going to be at -1, -3. It's going to shift to the left 1 unit and down 3 units. But to worry about the shape, remember we make that shape chart, and you have to imagine that little square is there on the x, even though it's on the outside of the parentheses. So we make our chart. Again, we can just pick very simple ones, and this time the equation we're going to use is 3x squared. If I plug in 0, I get 0. If I plug in a 1, remember you're doing the exponent first, and then you're multiplying by 3. We'll get a 3. 2 squared will get me 4, and then I multiply by 3, and I will get 12. And that's probably plenty big enough. 0, 0, 1, 3, and 2, 12 is not going to fit. It's going to be somewhere up there. But we get the idea. We can use symmetry to shift that onto the other side. And
you're off the charts.
We are off the charts. That is not our final answer, remember, because we have to shift. The vertex is not at 0, 0. The vertex is at -1, -3. So we need to shift each thing left 1 unit and down 3 units. And it's going to look like this. Maybe. Now, Mrs. Kendra, what do you notice about this graph compared to that very first one that we did? Yours was really wide.
Wide, and it had a 1/3 in front.
Okay. And then the one we just did had the 3 in front.
It's skinny with a 3 in front.
Right, so when we talked about our stretching and compressing, remember if you have a large number out in front, that's going to stretch it. And if you have a fraction, that's going to compress it or squish it down.
Right. Oh, it still works for parabolas too.
It does.
Huh.
Okay.
All right, let's take a look. This one's already drawn in there for us. All right, we need to find the vertex. That's pretty easy. Let's just find that point right there. So it looks like we're going 1, 2, 3, 4 over and up 3. So 4, -4, 3 is the vertex. So that's going to be our H and our K. And we have to determine by looking, or determine A by looking at the points on the curve from the vertex. Okay. Normally, on a regular, everyday parabola, you're going to go over 1 and down 1, or over 1 and up 1 to get the next point. Well, this one, if I start at the vertex, I go over and then down 2. So that's a little bit of a change. Our stretching, our vertical stretch now is twice as big. So that means our A is a 2. And the fact that it's upside down tells us there's a negative in front of that. So if I'm going to write y equals a x minus h squared plus k, let's plug in what we know. We know that a is -2. H we said was -4, but this negative makes it negative, which would be positive. And then the 3, whoops, I need my little square, the k is our 3. So that is the equation of that picture. So you have to do a little detective work to get all the pieces. All right, the trickiest one is this 2 part, but if you just see how many, or how it changes from the 1 and 1, you can find that out. And remember, wide ones are fractions, skinny ones are bigger numbers. All right.
I think that'll do it.
Okay, well, can't wait to see you in class.
See you guys.
Ta-ta for now.